Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Tight Fit 4 by the Bard. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in each row, column, and box without repetition. We have killer, or killer cage Sudoku, where digits in cages must sum to the number in the top left corner of the cage. And I guess they're all the cages are all in the same box, so there's no need to say anything about no repeats. But, for example, these two digits must add up to 15, these three must add up to 12, these two must add up to 15, these two must add up to 12, etc., etc. So, for example, if this were, say, a 4, and this would have to be an 8, because these two digits must add up to 12. And we also have crop key pairs, where digits separated by a black dot must be in a 2-to-1 ratio, and digits separated by a white dot must be consecutive. So, for example, if this were, say, a 4, this would have to be 3 or 5 to make sure that these digits are consecutive, and this would have to be 2 or 8 to make sure that these digits are in a 1-to-2 ratio with each other. And those are examples of how crop key pairs work. And finally, we have region sum lines, where box borders split blue lines into sections, and the digits on those sections must sum to the same value. And different lines may have different values. So, for example, on this outer line, these two digits must sum to what these three digits sum up to, which is what these two digits must sum up to, which is what these three digits sum up to, etc., etc. And these three digits must sum up to what these three digits sum up to, which is equal to what those three digits sum up to, which is equal to what those three digits sum up to. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing that comes to my mind is column 1. Because we have two cages, which have 2 cells each, which must add up to 15. The only possible combination for that is 6, 9, or 7, 8. So this must be 6, 9, or 7, 8 here in all the 15 cages. So let's do that. And also, in addition, we have column 1. We have 3 cells, which must add up to 12, without a 6 or a 9, because we have a 6, 7, 8, 9 quadruplet in column 1. So you don't have a 6, 7, 8, 9 available anymore in that column. Well, what's the max you can have for 3 digits? It's 3, 4, and 5, which adds up to exactly 12. So this has to be 3, 4, 5, because if you go away from the maximum, you won't ever add up to 12 then. That forces this to be 1 or 2, and this to be 1 or 2. Okay. Let's see. We know the sum of these two digits. Okay, so the rest of this lower left-hand box, because there's a 6, 7, 8, 9 quadruplet, it must be 1 through 5. Well, this is at most 4 and 5 here. In fact, so that means this region sum line, the sum must be at most 9. Well, the thing is, actually, what's the minimum here for this cage? It has to be 1, 2, and 6, which adds up to 9 also. So the maximum for this sum is 9, and the minimum for the sum is 9. So that means they must be equal. Because if you try to minimize anything else here, that won't equal the sum of this. And if you try to increase values here, that will not equal the sum there. So this must then be 4, 5. which adds up to 9. This must be 1, 2, and 6 to add up to 9. That eliminates 1, 2, and 6 in the rest of the column, so this cannot be 6 or 9. So this becomes a 7, 8 pair, which eliminates 7, 8 in the rest of the box. This is a 6, 9 pair, which eliminates 6, 9 in the rest of the box. This can no longer have 7 or 8 in it, so it cannot be 4, 8 or 5, 7, so it must be 3, 9. That leaves this digit as 4 or 5, because those are the only digits possible remaining in column 2. Well, 4, 5 only adds up with 4, 5 to add up to 9, so this is 4, 5. What are the remaining digits in this left central box? It must be 7, 8, and 9. So this adds up to 24 all the way around. So this must be 7, 8, 9, 7, 8, 9, 7, 8, 9. 4 and 5 is always obviously consecutive with 4 and 5, but then this must then be 3 or 6, because we have a 4, 5, 4, 5 pair already in the box, because this must add up to 9 again. And 4 can only add up to 9 with 5, and 5 can only add up to 9 with 4. So this has to be 3 or 6, but it cannot be 3 because of the 3, 9 pair in the box. So this is 6, which makes this 5, which makes this 4, which makes that 5, which makes this 4. Okay. Remaining digits in this upper left-hand box are 1 and 2. This is 6, 7, 8, 9. It's consecutive with 5, 6, 7, 8, and 9. But it cannot be 7, 8, 9 because of the 7, 8, 9 triplet in the row. So this has to be 5 or 6. That's only consecutive with 6 or 7. So this is 8 or 9 there. So, in order to have, we know 7, 8, 9 cannot appear in any of these cells in the outer boxes, or the corner boxes, I should say. So where are 7, 8, and 9 going to be? They have to be in the cages, and we know this cage cannot contain 2 digits out of 7, 8, or 9, right? It's 3, 9, or it's 4, 8, or it's 5, 7. It can contain 1 digit, but that's it. And it must contain 1 digit. Well, if this is 6, 9, then where are the 7, 8, and 9 going to be in here? They can't, right? Because they can't appear in any of these 5 cells in any of the corners because of the 7, 8, 9 triplets that are in those rows and columns. So this has to be then 7 and 8. And this must be a 3, 9 pair, because there's no other place for 7, 8, and 9 here, except for this way. So 7 is consecutive with 6. 3, 9 eliminates 6, 9 in the rest of the column, so this is 7, 8. Again, 7, 8, 9 cannot be here. Where's the 9 then? 9 has to be here, so this is a 1, 9 pair, adding up to 10. These digits are consecutive, so it must be 9 and 8, which makes this 7 and 1. This 1 eliminates 1 here, so it's 2. Which eliminates 2 there, so it's 1. Which eliminates 1 there, so it's 2. So this cannot be 2. This is 12 without 1, and this 7 eliminates 7 here. So this is 8 and 7. This 9 eliminates 9 here, so it's 3 and 9. To add up to 12 without 1 and 2, and again, it has to be 3, 4, 5, because that's the minimum now. So this must be 3, 4, 5, which makes this 1, 2, 6 also. That leaves this digit as 6, this digit as 5. And since this is 5, this must be 4 to add up to 9 on this region sum line. That leaves 2 and 3 remaining in row 3. Okay. Again, we have 6, 7, 8, 9 already accounted for in column 9. So this 12 cage cannot be sorry, has to be 3, 4, and 5 because that's the maximum it's allowed, and that's equals to the exact value we need. So that forces this to be 2, which makes this 3. This again must be 1, 2, and 6. And we know 6 is not consecutive with either 1 or 2. So this is 1 or 2, which forces this to be 6. So this cannot be 6 here. Remaining digits in row 7 are 1, 3, and 5, and this can't be 3 or 5 because of the 3 and 5 in the column, so this must be 1, which makes this 3, this 1, and this must be 5. That makes this 5 and 4 to add up to 9, and that makes this again 2, which makes this again 3, 4, and 5. So this is 3, 4, and 5, this is 1, 2, 1, 2, and 6. To add up to 9. That eliminates 3. This 3, 4, 5 triple eliminates 3, 4, 5 in the rest of the column. Or sorry, row. So this is 9. That's 3. This 9 eliminates 9 here, so it's 6 and 9. This 8 eliminates 8 here, so it's 7 and 8. Okay. So. Okay. We have pairs that are in 1 to 2 ratios. Okay, this has to be consecutive, so there must be an 8 there, which means this cannot be 8 here. For consecutive digits, you cannot have 2 of the digits from 3, 4, and 5. So you could have 1, 2, 3, no 2, 3, 4, no 3, 4, 5, no 4, 5, 6. So you could have 1, 2, 3 here. Is a possibility. So 1, 3, 1, 3, and 2. Or it could be 5, 6, 7. It cannot be 2 digits from 7, 8, and 9. So that eliminates 7, 8, 9, and 6, 7, 8. So this has to be either 5, 7 with 6 or 1, 3 with 2. But if it's 1, 2, 3, that eliminates all possibilities for that cell. So this cannot be 1, 2, 3. Therefore, this has to be 5, 6, 7. So this is 5, 6, 7, which eliminates 5, 6, and 7 in the rest of the row. So this can't be 5, this can't be 5, this can't be 7, that can't be 7. 6 is in a 1 to 2 ratio with only 3, so this is 3. That's consecutive with either 2 or 4. This 3 eliminates 3 in the rest of the row, so now we have a 4, 5 pair, which eliminates 4, 5 in the rest of the row. That means this can't be 4, this is 2. Which makes this 1, which makes that 2, and makes that 6. This 2 eliminates 2 here, so it's 1 and 2. And we have a 1 to 2 ratio here, without a 3 and without a 2. That eliminates 1, 2, 3, 6, and 2, 4, so that leaves 4 and 8 remaining. So this must be a 4, 8 pair. This 2 eliminates 2 here, so this is 1, which makes this 2. This can't be 1 or 2, so it's 6. This can't be 2 or 6, so it makes that 1. This can't be 1 or 6, so that makes that 2. And we have 8 ones. We know where the last one has to be. It has to be here. We should have 9 twos. We do. These digits are consecutive, so it's either 3, 4, 4, 5. But if it's 4, 5, that would eliminate all possibilities for that cell. So this must be 3, 4, which makes this 5. Which makes this 4, which makes that 3. Therefore, that's a 5 now. This 3 eliminates 3 here, so it's 4 and 3 to be consecutive. This cannot be 8 because of the 4, 8 pair. This cannot be 8 because of the 4, 8 pair. Also, this 3 eliminates 3 in the rest of the column. This digit has to be a 9 because that's the only digit remaining. That 9 eliminates 9 here, so it's 7, which makes this a 9 and an 8. This 8 eliminates 8 here, so it's 9. This can't be 7 or 9, so it's 8. This can't be 9, so it's 7. These digits are consecutive, so it must be 7, 8, or 8, 9, so this cannot be 8 here. This 9 eliminates 9 here, so it's 7, which makes this 8 and 9. This 7 eliminates 7 here, so it's 5 and 7. This can't be 7 or 9. That forces this to be 8. Again, you can't have 5 here. You can't have 5 here. these digits are consecutive. If it's 3, 4, it would eliminate all possibilities for that cell. So it cannot be 3, 4, it's 4 and 5, which means this can't be 4, it's 3, which makes this 4, which makes this 5, which makes that 3. This 5 eliminates 5 here, so it's 4, which makes this 5. This 4 eliminates 4 here, so it's 8 and 4. 8 eliminates 8 in here. This can't be 7 either, so this is 9, which makes that 8. This 9 eliminates 9 here, so that's 7, which makes that 9. And that's a solution. Yep, fairly straightforward. Yep, just using the restrictions we had, and the most restrictive ones were these and these. And that led to what these could be. So that was it just basically flowed from there. Could there be another approach? Obviously there could be. There's also Fist-Maffel's ring, which we could have done, but that's a little bit more advanced, and it's not necessary, this one. It does fit very well because of the way that the cages are, but in the rings, but not really necessary in my opinion. And this is much easier to explain here, right? So it flows very well going this way. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.